All right. Getting observability right in multi-cloud environments is critical for our customers. I'm Neelo Bustani. I'm a senior solutions architect at AWS.
I'm Santosh Mohanty, Senior Solutions Architect at AWS.
Santosh and I have both been working with our multi-cloud customers, and today we'll share some patterns that we see when implementing observability for multi-cloud workloads. So before we get into that, a quick word about multi-cloud. At AWS, we define multi-cloud as the use of at least 2 cloud service providers to operate your IT solutions and workloads. AWS is committed to helping you succeed at your multi-cloud strategy. Now, customers typically tell us the reason for selecting multi-cloud is either differentiated capabilities or as a result of mergers and acquisitions or regulatory compliance. With AWS, you'll have the freedom to choose and to make the choices that best suit your needs and innovate wherever your workloads are. So AWS's multi-cloud approach is based on the open standards-based cloud maturity model by the Open Alliance for Cloud Adoption. Now, multi-cloud is not just about technology, it's also a strategic decision. So AWS aims to help you create capabilities in both technical and non-technical pillars of people, process, and technology. In this session, we'll be sharing some cloud-agnostic guidance and patterns to help you with your multi-cloud needs. So coming to the foundations of observability, you all are probably already familiar with this. We want to get good at detecting, investigating, remediating issues with the end goal of reducing our mean time to resolution and understanding our system's behavior. And to do this, we collect signals from our applications in the form of metrics, logs, and traces. Metrics, logs, and traces are the first building block of the observability strategy. Here, we may have to ask, how do we instrument our workloads across both the clouds so that we can gather telemetry consistently? Then we process this raw data into useful information. At this stage, we may have to ask, what signals do we prioritize and keep as we scale? Our storage strategy answers questions about cost-effective and performance storage for each data type. And then what visualization tools do we use to make sense of all of this data? So these questions are going to be part of any observability strategy. But when it comes to multi-cloud, there are a few challenges that get magnified. One is complexity. Customers tell us that with multiple clouds, there's multiple tools and service dependencies, and teams find it cumbersome and time-consuming to go between dashboards to arrive at the root cause of issues. Then there's process overhead. Multiple clouds means multiple services to instrument, and that means more work. Also, team members have focused knowledge in their own tooling, so there's a learning curve to overcome. And then also customers tell us that it may take months to get all of their observability tooling to talk to each other. Finally, scale. So with multiple clouds, you have multiple streams of telemetry, and that increases the amount of data that we need to handle. How do we tackle ingestion latency? How do we manage our query performance? And then how do we make sure that our data egress charges don't spiral out of control? Now, these are problems that impact customers as they adopt multi-cloud. And it doesn't matter which cloud providers you're using. They have a real impact on teams and then eventually the business. This is exactly why we need to discuss systematic approaches and patterns like the ones we're going to do right now. So we've seen 2 main patterns, the centralized collection pattern and federated query pattern, and then some hybrid combination of these. We'll discuss these 2 patterns and then also implementation approaches using open source and cloud native tooling. Now, You may be using partner solutions for your monitoring, and that's fine. When you look under the hood, you'll find these same patterns at work. So coming to centralized collection pattern. Here, we are going to take an example with AWS and Google Cloud. We have workloads running in the two clouds. This is just for simplicity. This could be any clouds. So we have telemetry being generated in AWS and Google. Now we need something to collect all the signals and export it out. So we have a collector agent that we would have running on our compute workloads. Now for the infrastructure telemetry, this usually goes into the native tooling that each cloud provider has. So for this, we may have to create configurations, or we may have to build some mechanisms to export the telemetry. Then we need to make sure that the signals get reliably to its destination. So we have an ingestion layer where we do buffering, routing, and handling back pressure. Now, in order to make querying easier, we would like to have our data format in a common format. So we have a normalization layer where we collect all of the data and convert it to a standard format. Now, all of our data ends up in the storage layer, where it holds the full context of our request, and we can query it from our visualization layer to build a global view of our application. So that was the high level for the centralized collection pattern. Now let's look at an open source implementation of this pattern. So for the collector, we've chosen the OpenTelemetry collector. A quick word about OpenTelemetry. It's a standard by CNCF. It's gained popularity because it's vendor neutral, and it provides a standard way of collecting and processing your telemetry. It has support for multiple coding languages and auto-instrumentation. And then there's a growing ecosystem of support around this. So that was OpenTelemetry for our collector. For our ingestion layer, we can choose Kong as the API gateway and router. And we can have Kafka as the durable buffer to handle large volumes of requests. For normalization, we can have OpenSearch Data Prepper to standardize timestamps, normalize service names, do aggregation, and then we'll index our logs and traces with OpenSearch. For metrics, Prometheus specializes in time series for metrics, so that's what we have, and then Grafana for our visualization layer to correlate everything and have a global view of your multi-cloud application. Now, if we want to eliminate complexity a little bit more, we can have managed open source services. So we use Amazon Managed Service for Prometheus, Amazon OpenSearch, and Amazon Managed Grafana. Customers love the out-of-the-box security and abilities to scale that comes with these services. For instance, with Amazon Managed Prometheus, you can have 1 billion time series. And you find that the ingestion layer is no longer needed because it's built into the managed services. And all of this is still in keeping with open source and maintaining interoperability. So let's see a cloud-native implementation approach now. Here we're going to choose Amazon CloudWatch as our centralized storage. So this would be really straightforward for AWS workloads. The infrastructure telemetry is already going into Amazon CloudWatch, and we have the Amazon CloudWatch agent for our compute workloads. We can use the same Amazon CloudWatch agent for our Google Cloud workloads as well. Now, for the infrastructure telemetry in Google Cloud, here we need to build a pipeline to export this, so we can have Google Pub Sub, and then we can do the normalization in AWS Lambda and have all of our telemetry end up in CloudWatch. And CloudWatch is also our visualization layer where we build dashboards, we do troubleshooting, we can do anomaly detection, and then have automated remediations. So to sum up the centralized collection pattern, essentially we reduced our complexity by having a standard collector and by normalizing all of our data to a common format. Our process overhead is reduced because teams have fewer tools to learn and implement. And then we have a global and unified view of our multi-cloud application. Now Santosh will cover the federated query pattern.
Thank you, Nilo. So we just saw how we can use centralized collection pattern to consolidate all your data from different sources to one single space to get that unified observability. However, this approach may not be possible for all customers in all scenarios. There may be some use cases where you need to keep your data in its original location. It may be due to your compliance reasons, or it may be due to your cost reasons. In those use cases, we can use federated query pattern. Let's see what is federated query pattern. So, like I said before, federated query pattern allows you to query data across multiple sources while keeping the data in its original location. Let's take Nilo's example. What we have is your application as well as your infrastructure telemetry data is been generated and collected using collectors and stored locally in AWS and in GCP. The end goal is to create that unified observability for your multi-cloud application. In federated query pattern, we will have a federation layer that will take the query from your visualization tool and split it into multiple sub-queries for each cloud provider. And once the queries are executed in this specific cloud provider, the results are then aggregated and presented to the visualization tool. And to process and plan the queries, the federation layer uses metadata catalog to store the schema information. So we just learned what is federated query pattern. Let's see how we can implement this using open source as well as cloud native tools. So let's first look at open source. For storage, we will store the telemetry data locally, which means we will store all your AWS telemetry data in Amazon S3 and all your GCP telemetry data in GCP storage. Now, in federation layer, we will use Trino, which is an open source tool, as our query coordinator. And we will use Hive Metastore as our metadata catalog to store the schema information. So, and also we will use Grafana as our visualization tool. Now looking at the flow, Grafana will send queries to Trino. Trino will break down these queries into sub-queries, and then we can use Trino connectors to execute these queries in each cloud provider and retrieve the data from AWS and in GCP. And then we will, once the data is retrieved from each cloud provider, Trino can aggregate those results and present it to Grafana for visualization. So that was open source tool. Now let's look at how we can implement this using cloud native as well as managed open sources. So we will keep the storage same. We will store all your telemetry data in AWS telemetry data in Amazon S3 and your GCP telemetry data in GCP storage. For federation layer, we will use Amazon Athena as our query coordinators, and we will use AWS Glue as our metadata catalog, which will help the federation layer to plan and process these queries. Now, we will use Amazon Managed Grafana as our visualization tool. Looking at the flow, Amazon Managed Grafana will send the query to Athena. Athena will process these queries and breaks these queries down to multiple sub-queries for each cloud provider. And once the data is retrieved from AWS and GCP, Athena will process these results and aggregate and present it to Amazon Managed Grafana for visualization. So, though we just learned about these two patterns and how we can implement this using cloud native as well as open source tools. Now let's look at some key decision points between these two patterns. When we look at these two patterns, the choice really comes down to your business drivers. Let's If you're looking for like the central or single source of truth, you should go for centralized collection pattern. Think about how you can get faster, better analytics or better governance. Those things will be done in centralized collection pattern. But if you're looking for that, like if you have compliance or data residency requirements, then you should be looking at the federated query pattern. With centralized hub, you're optimized for speed and simplicity, which means faster queries, easier governance. However, federated query pattern gives you that flexibility and data freshness. Your data stays put, your storage costs are also optimized, and you're always working with the latest data. Let's look at some drawbacks or some of the trade-offs, I would say. Centralized collection pattern increases your storage cost. However, in the same time, federated query pattern introduces query latency as well as its more complex orchestration. So while you make your decision, it's very critical to consider these trade-offs early in your decision-making process. So think about, like, when you make your decision, consider factors like what is your compliance requirements, what is your data freshness requirements, how cost sensitive you are. And all these questions will lead you to the right design pattern. Now, remember this, like this is not either or decisions. You can always do a hybrid also solution depending on your use case. Now let's look at a customer story. Philips 66, a global energy company, they had challenges managing thousands of applications across multiple cloud providers. They have around 70% of their workload in AWS, but they have footprints in multiple cloud providers as well as on-premise. So as a solution, they implemented centralized collection hub pattern, also adopted open telemetry for their data collection, and used tools like Amazon Managed Service for Prometheus or Amazon Managed Grafana to get that unified visibility they are looking for. With that, they were able to get 30% faster mean time to resolution, which is really great. Now let's look at some next steps and resources. Let me highlight some of the breakout sessions at reInvent 2025 that deepen your multi-cloud expertise. These sessions are recorded as well, so it will be available after reInvent. And also, do not miss our multi-cloud kiosk at AWS Village. It's a space where you can see live demos, you can deep dive into specific use cases, and also talk to our experts who can guide you, ask you if you have any questions, they can answer your questions, as well as if you're tackling any problems, they can help you solve that problem as well. I also wanted to highlight some resources that will help you in your cloud journey, whether think of it as your toolkit if you are strategizing your multi-cloud architectures, you are creating new architecture, you are optimizing your existing architectures. These resources can help you to move faster. Again, thank you very much for your time. Hope this session was useful for you.